Hi, my name is Merlin. Uh, Today I'm gonna talk about what I learned today. This is not working. Yeah, this is perfect. Yeah. So recap. Uh, I'm just gonna talk about what I learned today. Uh, our topic is bootloader, but our main topic is how to create an operating system. When you first, uh, even I was really surprised, and I really think that creating an operating system is really challenging, and I think it is really difficult. But fortunately, we're not building like big OS, like really big software. Like we're not creating a the window like OS, Linux, not like OS like Mac OS. We're not building like that. We're just building the like minimal operating system. But to build an operating system, we have to know about like important thing how we how we use operating system. Like you have to like keep questioning yourself how how we can use our window or Mac OS or Linux by just turning on your computer. So so when you just when so there's like your computer, uh, and you just put the power on off, and you can see it's loading, and you can see well, like window or some kind of thing. Uh, but the reality is, it does not happen like a magic. Uh, Everything is related to the computer science. So we're just gonna go like really deep part of it. Not really deep, but I'm just gonna talk about what's happening under the hood. So actually, I'm trying to turn on this. There's gonna turn on. There's gonna be BIOS, and there's gonna be a bootloader. There's bootloader, and that's gonna be running your OS kernel. And so the boot BIOS is basic input output system. So what it does is it's just like checking your it's just checking your hardware stuff, and your it's just like doing the post thing. So you might so what is the post? It's just like power. I think it was an on and off uh, power off system test, just like that. But I'm not sure about it. But basically, forget about this. Basically, what BIOS does is checking our hardware, like CPU or RAM, ROM, those kind of stuff. So, but our main topic today is not OS kernel, the bootloader. Uh, Bootloader is the one who wanted boot your your operating system kernel. So bootloader is kind of really big concept. So there's a research paper I read. So so bootloader in this document is saying that it's the first software that starts running after BIOS. So that bootloaders are responsible for initializing hardware and loading kernel image into RAM. So there's a key thing. We already know, we can understand what is initializing hardware, but we don't get really the meaning of the kernel image. What's the kernel image? The kernel image is just like uh, just just a compressed program like file of the kernel. If you run it, it's gonna be decompressed and it's gonna be run as the kernel or so. So so bootloader is um, just gonna try elaborate more. I think there's really cute thing. I think I have to really visualize it, how it does it works. And so bootloader, as you guys know, it's just like booting up your comp. You're like it's just like steps of loading the kernel image. So to visualize the process, it looks like this. It executes from flash and the post. This is just boot up process. So that could be, it is a kind of, there's like BIOS logic, BIOS explanation, and bootloader explanation. And it relocate RAM and set up console your interaction, setting drivers for kernel image, choosing kernel image, and jumping to kernel start address. And the post in here is power self test. Yeah, power on self test. Power on self test. Power on self test. Power on self test. So that's the post of it. So the bootloader is the one who finds the kernel image. I put it just like we gonna yes, bootloader is the first software of the BIOS. It's gonna load the kernel image into RAM. I'm not just I'm not gonna rely on the paper anymore. I'm just gonna doing it in like real mode. To understand bootloader, so bootloader is a software. Like, actually, if you're trying to make a bootloader, it is kind of simple. But the thing is that you have to understand how does it works, how we create a bootloader. To understand like bootloader thing, you have to know about where it is stored. Bootloader is just that we can write bootloader. So bootloader is a code. We can write into assembly, but the thing is that it cannot be erased. Yeah. So like if we turn on our application on the operating system, and when you turn off, it's going to shut down, right? But this one, bootloader, has to keep it because there is a step of it is the software of the BIOS, so we have to keep it memorized. So which means that it cannot store in the RAM. It means that we can store into ROM. Not exactly ROM. I think it was like, yeah, it was the hard disk. Yeah, hard disk. Yeah, it was the hard disk. Typically, I'm talking about wartime, but right now we can store in the flash memory because that if we try to store the bootloader in the hard disk, that means we can rewrite on it. But right now, in modern operating system, we store into the flash memory, but we're just gonna keep it in like fundamental of it. Hard disk. So what is the hard disk? So if we try to visualize it, hard disk is just like this. Just like there's a round platter, like a hard disk, like a disk, like a CD, like round thing. These are called platter, and there are arm on the like track setting. And if you're trying to visualize this more, yeah. So I'm sorry, there's no ink on it. So, so this is how it looks like, and we store this bootloader code into first sector of the hard disk. So it's like this part, and this storage amount is 520 bytes. So if you're trying to make make a bootloader with the assembly code, but and and you're able to like hear the concept of the limitation is 512 bytes. The reason why you have the limitation story is 512 bytes is because bootloader has to store in the first sector of the hard disk, and hard disk sector is 512 bytes. So that is why bootloader limitation, the storage is 512 bytes, because that is related to hardware. And this is and 64 byte here. That is validation, and this for 500 terabytes minus 64 equals to the my brain is not working. I think it was 446. 446. Wait, no, 448. Yes, it was like 448, or yeah, this is right. So so that means that we put all the bootloader logic into 448 byte, and that is known as called a master boot record. So it's just like master boot record sounds really abstract and sounds really difficult, but what I think of master boot record is the one who do all the logic, and we can call it the master. But the thing is that how we really find this sector? How? So how hard disk works is, I talk about this ARM, right? Actually, the head of it, this last part, and I also said that the hard disk, the plotter, looks like a CD. More elaborate, it's just like um, like 70, in 1970s. There's such a thing as, like, I forgot the word of it. Like it was like here. It was like similar to here. I forgot the word. Mm. But by the way, so in the 1970s they put like round thing, not like the CD. They put like big round black thing, and there's many round sector of it, round track of it, and when you put some kind of needle here, and when you rotate this round thing, the music plays, right? And this is kind of similar thing. How it finds is it rotates the plotter, and when it encounters this part, it's gonna run the bootloader. And yes, the boot based on the bootloader speed, uh, that is kind of related to the how your operating system setup. Uh, sorry, not operating system setup. That is how your computer is fast or not. That's kind of related, because if your bootloader is slow, that means like that your booting is slow, and that could be uh, postpone your opening the operating system. So which means that you cannot eat. That means that also your well, you cannot. That means I sorry. Mm, that means that your operating system could be kind of slow at the first time. Mm, more about it. I think this is it. This is hard disk in here. And also, by the way, we can put our text on the screen, right? So actually, we can do that in the bootloader, and we are doing it by using BGA hardware, BGA hardware, and there's also rule for it, like a promise for it. We have to use we have to begin because you have to store our text into memory address, right? Because this is directly linked into the hardware, and you have to store the text on the hardware memory address. And the thing is that there's already promise for it. To show it to the screen, we just have to put our text beginning from 0xb8000. This is memory address. Yes, and I think that is a very key part. MBR 448 byte we store in the far sector of the hard disk. Bootloader is the one who defines the current image and wrote to the RAM. And the reason why we don't put bootloader into RAM is we have to keep this code even though we have to keep alive this code after despite of the turning off the computer. And to print the text on the screen, we have to start beginning of the 0xb1000 memory address, and I think this is it. This is kind of very key concept of bootloader. Hmm. Oh yeah, there's more. Actually, if you're really interested in the bootloader, you gonna be you're gonna write some code of it, but you're like but the thing is that you're able to uh, uh, you're able to uh, like hear these kind of concepts, EAX, like, and AH and AL, like something like that. So that is E is stand for the extended, and to visualize it, this is the AL and AH, and there is 8 bits, and there's a storage for these are the EAX, and I think this is it. So that is the reason why such a thing EAX is exist is EAX is just the I think that is the register. Yeah, I think it's a register. It is a type of register, but if you're like using x86 rather than x64, you're just gonna use the extended register, which is bigger than 64 bit. So that is why you can extend it. And the reason why there's such a thing AHAL, like high and low bits, because sometimes you want to put really small value on it, but that means you don't have to use 16 bits for it. You can use 8 bits to store really small value. So that is, I think, that is why we separate into AH and AL. And I think there's more. And the bootloader should be on the real mode. So what's the meaning of the real mode? The real mode is Real mode is a 16-bit environment. Yes. Yeah, I think that is how it works. But the thing is that when you're trying to write a bootloader, or even using Rust, uh, you don't have to really specify all the pointers to store some to store text onto some kind of specific memory address because there's already built-in bootloader image library, so we can just utilize it, and we can just use the BGA hardware and BGA buffer on it. We don't really have to put us like make this bootloader into assembly. Using assembly could be really nice, but uh, but but I think using assembly is that kind of that could enhance your insight, but I think there's no disadvantage of using whatever what your language you use for the program bootloader. You just have to understand how bootloader does, why we need this kind of storage, and why we have to put into this sector, and how this works, and yeah, I think this is it. And yeah, so this is what I learned today. By the way, and this is my first time presenting into Seraphim and with the whiteboard. And I could be really bad the first time, but I'm pretty sure I practice it and I'm gonna be better. So yeah, this is it. Goodbye.